Question number 16. In the mountains of Brazil, Barbacenia tomentosa and Barbacenia macrantha, two plants in the Velloziaceae family established themselves on soilless, nutrient-poor patches of quartzite rock. Plant ecologists Abrahão and Patricia Britto Costa used microscopic analysis to determine that the roots of B. tomentosa and B. macrantha, which grow directly into the quartzite, have clusters of fine hairs near the root tip. Further analysis indicated that these hairs secrete both malic and citric acids. The researchers hypothesized that the plants depend on dissolving underlying rocks with these acids, as the process not only creates channels for continued growth but also releases phosphates that provide the vital nutrient phosphorus. Which finding, if true, would most directly support the researchers' hypothesis? Is it A. Other species in the Velloziaceae family are found in terrains with more soil but have root structures similar to those of B. tomentosa and B. macrantha? B. Though B. tomentosa and B. macrantha both secrete citric and malic acids, each species produces the acids in different proportions. C. The roots of B. tomentosa and B. macrantha carve new entry points into rocks even when cracks in the surface are readily available. D. B. tomentosa and B. macrantha thrive even when transferred to the surfaces of rocks that do not contain phosphates. So, we need the finding, if true, which will most directly support the researchers' hypothesis. So, here we are talking about in the mountains of Brazil, the two plants which in fact they grow on soilless, nutrient poor patches of a rock, quartzite rock. So how do they get their nutrition? The ecologists Abrahão and Patricia Britto Costa, they have used microscopic analysis, and what they have seen is that these plants, they are growing directly into the quartzite, and what has happened is the clusters of fine hairs near the root tip, that these hairs secrete malic and citric acids. Because of these acids, the researchers are hypothesizing that the plant depends on dissolving the underlying rock. So basically the acids from the plant, they are dissolving the rock with these acids, and because of that process it creates channels for continued growth. That is, the plant is able to grow, and also it releases phosphates that provide the vital nutrient phosphorus. So which should we choose? So if you said C, well done, that is the best answer, because it presents a finding that, if true, would support the researchers' hypothesis about the plant's dependence on dissolving rock. The text indicates that the roots of the two plant species grow directly into the quartzite rock, where hairs on the roots secrete acids that dissolve the rock. The researchers hypothesize that the plants depend on this process because dissolving rock opens spaces for the roots to grow and releases phosphates that provide the plants with phosphorus, a vital nutrient. If plants carry out this process of dissolving rock, even when the rock already has spaces into which the roots could grow, that would support the researchers' hypothesis, because it suggests that the plants are getting some advantage, such as access to phosphorus from the action of dissolving rock. If the plants don't benefit from dissolving rock, they would be expected to grow in the cracks that already exist, as doing so would mean that the plants don't have to spend energy creating and secreting acids. If, however, the plants create new entry points by dissolving rock even when cracks already exist, that would support the hypothesis that they depend on dissolving rock for some benefit. Carve new entry points into the rocks even though the cracks are readily available, these plants are secreting acids and dissolving the rock. Choice A is incorrect because the existence of soil-inhibiting members of the Velloziaceae family with similar root structures to those of the two species discussed in the text wouldn't support the researchers' hypothesis that the species discussed in the text depend on dissolving rock. If other such members exist, that might suggest that the root structures can serve more functions than secreting acids to dissolve rock. Since dissolving rock may not be necessary for plants living in soil, but that wouldn't suggest anything about whether the species discussed in the text benefit from dissolving rock. Choice B is incorrect because differences in the proportions of citric and malic acid secreted by the two species would be irrelevant to the hypothesis that the plants depend on dissolving rock. There is no information in the text to suggest that the proportion of each acid has any bearing on the process of dissolving rock or on any benefits the plants might receive from that process. Choice D is incorrect because if the two species thrive on rocks without phosphates, that would weaken the researchers' hypothesis that the plants depend on dissolving rock, partly because dissolving rock gives them access to phosphates. If the plants can survive on rocks without getting a vital nutrient by dissolving these rocks, then either the nutrient isn't actually vital for those plants or they can get the nutrient in some other way than by dissolving rocks.